So, I'm Dr. Bharat Pandey, again back with you in my new video after a prolonged time, and I'm very thankful that subscriptions are increasing day by day. I hope they are liking my video in my YouTube channel. So, I'm Dr. Bharat, Assistant Professor in Department of Chemistry from SBS Government PG College, Rudrapur. My email ID is, if you want to contact me, is drbharatpandey@gmail.com. Previously, I made some videos on a reaction mechanism, which was liked by many students and from various scientists from India and abroad. Then I make elimination reaction, that is part 1 and part 2. And after that, I prepared exploration techniques in optic region. And few days back, I've designed a virtual lab on chemical science. It's the first virtual lab in Uttarakhand. It consists of experiments very GC, sorry, not GC, it's NMR, MAS, IR, and TLC. So today what I'm going to teach you is the basic concepts in reaction and mechanism. So today what I am going to teach you in the slide I have presented is basic concepts in reaction mechanism, and we all know that what we mean by the reaction. Let me explain you. We are seeing that the organic molecule which have written the substrate, also known as substrate, are attacking reagents which attacks with the substrate. Between this, the product and the substrate are intermediate is formed, and are also known as the byproducts. And now this systematic, the steps, the systematic each step, that is describing details of electrons, movement of electrons, I mean, the energies during bond cleavage and bond formation, and the rate of transformation of reactants into products, kinetics, is all this is referred to as the reaction mechanism. Okay. Now coming on to the next slide, what question is that what is a covalent bond? Okay, the covalent bond, as we all know, the bond that is formed by the sharing of electron. Suppose A and B is there, and one electron of A and one electron of B, if they share together, a covalent bond is formed. Now there is a breaking of covalent bond. That means there is a fission of covalent bond. So the breaking of covalent bond can be cleaved, or they can be broken by two ways. That is a heterolytic cleavage or heterolytic fission, we can say, or homolytic fission. Now what is this heterolytic fission? Before going to heterolytic fission, we are seeing this arrow, that is a double-headed arrow. What it means, we can understand this double-headed arrow if we understand the heterolytic fission. Okay, now in this, the bond breaks in such a fashion that shared pair of electrons goes with one of the fragment, and you are seeing here that A and B, the bond formed by sharing of one electron of A and one electron of B, and this the straight line is showing a covalent bond. Now if both the electron goes to the B, there is the breaking of bond, and what is happening? Positive charge, because it is electron deficient, and a negative charge which is electron efficient, a negative charge is formed. Now similarly we are saying it here in case of A and B. If both the electrons are going to the A, there is a electron efficient, between negative charge is there on the A, and B is electron deficient, so positive charge is electron is on B. Now what is this some facts should be there about the heterolytic fission, the positive and negative. What are these? Okay. So now if any carbon that is bearing a positive charge, suppose A, we are talking about A, if it's bear a positive charge, we call it a cation. Now if a carbon is bearing a positive charge, it is known as a carbocation. And if it is bearing a negative charge, that is, in the example we are saying that B negative or A negative, in second one A negative, first one B negative. So negative charge, the anion, and if the carbon is having a negative charge, it is known as the carb anion. Okay. So now another factor, important fact, another is that heterolytic fission, it generally takes place in polar covalent molecules. Why it is so? The reason is the term which came, I hope everyone must be knowing, is the electronegativity. Now, what is this electronegativity? That electronegativity is the tendency of the atom to attract the shared pair of electrons. Suppose we are taking the example this A and B, and in this the B is more electronegativity, so its tendency will be that it will take both the electrons which are formed by sharing this bond, the bond will cleave, so it will take both the electrons towards itself, resulting in negative. So it's the tendency of this B to attract the shared pair electron towards itself, resulting in B negative. And here tendency of this A is at taking the shared pair of electron towards itself. So it means in first one B is more electronegative than A, and second one A is more electronegative than B, hence A negative. Okay, but in non-polar molecules, if molecules are non-polar, then it takes place in presence of catalysts, and these catalysts are, for example, they are anhydrous AlCl3 or um, anhydrous FeCl3, and there are many more. Okay, right. Now coming to this, another was our homolytic fission. Now what is this homolytic? As the name indicates, homo means same. So if this A and B are of same, that is, in the homolytic fission, one of the electron of the shared pair in the covalent bond, that is goes with each of the bonded atoms, the neutral species which is formed is the free radical. And we are seeing the sunlight and heat. So these reactions take place in sunlight and heat. Here also this, now you are seeing the half-headed arrow. What is this showing? The movement of unpaired electron. That is, the movement of single electron, means one electron is going here and other electron is going here, resulting in free radical. In chloride, both have same electronegativity. That is, the homolytic means breaking, same electronegativity here. Then what will happen? One electron will go towards C and one will go to another C, resulting in formation of what? The free radicals. We can say free radicals. What are free radicals? Free radicals are what? They are the unpaired electrons. It means single electron and single electron which are sorted by dot. Now, generally the homolytic fission takes place in non-polar covalent molecules in presence of sunlight and heat, means at high temperature. The free radicals which are formed, they are highly reactive, neutral and electron deficient species. I hope you are understanding. And now we have studied the homolytic and heterolytic fission. Now this another one will be studying about the attacking reagents. Now what are the attacking reagents? Also known as the organic reagents, right? So what are these? Let's see in the slide. The attacking reagents, they are of two types: electrophile, or we can say the electrophilic reagents, and the nucleophile or the nucleophilic reagents. Right? Now, electrophile or electrophilic reagent we are talking, what are these? Electrophiles, as the name indicates, they are electron deficient species, that is, it behaves as Lewis acid. It behaves as Lewis acid. Electrophile means they behave as electrophiles. Say all non-metal cations and metal cations which have vacant d orbitals. For example, we can say Ci positive, NO2 positive, or CH3CO positive, and there are many more. Lewis acids, which have incomplete octet. Example, we can say BF3, FeC anhydrous FeCl3 or anhydrous AlCl3, and etc. The non-metals, that is acidic oxide, non-metal oxides, acidic, CO2, SO2, and coming to the nucleophiles. Before going to the types of organic reagents, we are coming to the nucleophile, the name nucleus loving. They are electron-rich species which behaves as Lewis bases. Now, they attack, where they will attack? They will attack the electron deficient area. Okay? They behave, they will behave as a nucleophiles. That is, all alliance, Cl negative, NH2 negative, OH negative, and many more are there. Lewis bases, we can say NH3, H2O, ROR, ROH, etc. we can say, or pi bond containing compounds that are benzene, alkenes, and etc. So these are the regarding the electrophiles and nucleophiles. Besides this, I was just forgot to tell you about the electrophiles. That electrophiles are, if go to the classifications, electrophiles or the, we can say they are also known the catonites. In my previous slide, in my previous video, you will be all about the electrophiles. I just talked about the classifications, and classifications which I told you was that electrophiles are of two types: positive electrophiles, the neutral electrophiles, neutral, that is BFC, AlCl3, and the positive, that is the Cl, NO2 positive, CH3O, CH3CO positive, etc. And nucleophiles, the nucleophiles are the nucleus loving, as I told you regarding the classifications. Now nucleophiles are of three types. What are these three types? They are the negative nucleophiles. Number two, neutral nucleophiles, and number third was the ambident nucleophile, that is the CH3CN and etc. Examples are there which I told you: Cl negative, and the neutral we get water, ROH, NH3, that is the neutral electrophiles. I hope everyone must have the previous slides which I showed you. I I hope that is clear. If there is any query, I just told you about my email ID. You can ask me. And for more videos, please do subscribe, because the more videos on column chromatographies and atomic structures I am going to make, ionization energy will be also be there. Now, what will I am talking now? I am talking about the types of organic reactions. Regarding telling you about the organic reactions, the organic reactions are classified as, you all must be knowing, they are the substitution reaction, addition reaction, elimination reaction, rearrangement, and oxidation reaction reactions. There is the chart: substitution, addition, elimination, rearrangement, and oxidation reactions. Now, number one was our substitution reaction. As the name indicates, what are the substitution reaction? These reaction involves the displacement of an atom or a group by another atom or a group. Substitution reaction are also known as the replacement reaction or the displacement reaction. So what is written? The reaction involves the replacement of an atom or displacement of an atom or a group by another atom or a group. Now, this is RCH2, CH2X. X is any, what is this? Halogen. Now, this is the substrate, and here it is the attacking reagent. Is the Y negative, it means it's a nucleophile. Okay, now substitution reaction is taking place. What is happening? X is the leaving group, X negative, and Y attacks on the place of CH2 because the positive charge must be developed here. So it is the formation of the product. Now, substitution reaction which is showing are of following type: the nucleophilic substitution reaction, electrophilic substitution reaction, and the free radical substitution reaction. Right? Coming to the next is the addition reaction. We are not going in the detail. Excuse me. Now, addition reaction, as we are seeing, what is the addition reaction? There is a double bond and XY, then resulting in formation of this. There is a cleavage in the double bond, right? That the cleavage in the pi bond is there in addition reaction. Now, what is there? Now, these reactions, the addition reactions, they are characteristics of compounds that are containing the multiple bonds. That is, the alkene, alkynes, that is the double bond, triple bond, C double bond O, or we can say C triple bond N. They react by addition to the multiple bond. hence we can say that in addition reaction, there is increase in number of groups attached to the substrate. There is increase in number of groups attached to the substrate and decrease in unsaturation, because the pi bond here is double bond or a triple bond, it will break. So there is a decrease in unsaturation. So addition reactions are of four types as we are seeing. That is the electrophilic addition reaction, nucleophilic addition reaction, free radical addition reaction, or and the last is the concentrated addition reaction. The first three, electrophilic addition, nucleophilic and free radical. The first three are the two-step processes. Now these electrophilic addition reaction, nucleophilic addition reaction and free radical addition reaction are of what? Two-step processes. What? With there is the initial break, there is the initial attack by the electrophile, nucleophile or free radicals. And in the second step, it consists of combination of the resulting intermediates with a negative species, a positive species or a neutral entity. In addition, we can say in addition reaction, attack at the two carbon atoms of the double or triple bond is simultaneous. Okay, it is simultaneous. Now coming to this types of elimination reaction, I have made a YouTube video on the elimination reaction 1 and 2 that I discussed the alpha elimination and the beta elimination. So I told you about this also, that about this elimination reaction 2. Let us take a one look about the 1-1 elimination. So the two groups are eliminated from the same carbon atoms. You are seeing also A, B, X and W, the two groups, what are they? W and X are eliminated from the same carbon atom, and what this happened, they result in formation of carbines or the nitriles. So in this example also, CH3Cl, OH negative. Now what is this? Two groups will be eliminated, hydrogen and chloride. So what is there? It is resulting of CCl3, right? Hydrogen is removed and this negative, then again Cl and resulting with carbene, that is a CCl2. Now beta elimination, I told you about the beta elimination too. This is the name indicates that the 1-2 elimination. Now what is this? This is the most common elimination reaction in which the two groups Y and X we are saying are eliminated from the adjacent carbon atom. This is X from B and A from and W from A. So these are eliminated from the adjacent. Two groups are eliminated, or we can say groups are eliminated from the adjacent carbon atom. That is creating a multiple bond. You are seeing here A double bond, B creating a multiple bond. So, but in most beta elimination, the new bonds are carbon-carbon double bond or carbon-triple bond. The beta elimination reaction includes the acid catalyzed dehydration of alcohols. That is the Hoffman elimination and dehydrohalogenation. I've told you regarding this. To understand the elimination reaction, you can see my YouTube video on the elimination reaction part 1 and part 2. I discussed the full. Coming to the rearrangement reaction, very interesting reaction I must say. Rearrangement, as the name indicates, there is a rearrangement, arrangement of groups. Means what is happening, you are seeing in this diagram too, WAB. Now it is the ABW. Here is the rearrangements of the group. So now this about the rearrangement reaction. The molecular rearrangement includes, you are seeing, the migration of the atoms or a group from one atom to the another in the same molecule. The rearrangement reaction, it proceeds by the formation of the cation, anion or radicals. Now the 1-2 rearrangement, that is pericyclic reactions and metathesis, occurs via the rearrangement. The atom A is called migration origin and B is migration terminus. The migration of any substance from one atom to the another adjacent, it is called as 1-2 shift, but some are longer distances. types of the organic reactions we can say about the types of organic rearrangement we are talking about is the pinnacle rearrangement and the is a pericyclic reactions. Now, in this pinnacle rearrangement, there is a conversion of 2,3 dimethyl butane, 2,3 diol into what? 2,2 dimethyl butane 3-ol, as you are seeing in the diagram. In the pericyclic reaction, what is the pericyclic reaction? Its reaction involves the concentrated bond reorganization. You are seeing in the diagram that the reorganization, the deglycation pi electrons are there. So there is a bond reorganization and essential bond changes within the cyclic array of participation atomic center. Now, it takes place either photochemically, that is presence HV, or thermally, that is the delta, in presence of, or we can say in presence of heat and light. So, thank you very much. Uh, I hope everyone must be benefited from this, and if there were notes, if they can see from the slides. And for more videos, please do subscribe my channel. Thank you.